planning that minimize this pumping system
Mm-hmm.
and shift the city on the gravity side.
Right.
So two sides of the cost. One is infrastructure itself,
Mm-hmm.
which are pipe excavation, what is short with the minimum excavation in terms of maintaining the slope. At times we have pumping machinery as well.
Right.
So
Great.
two sides.
So you have combined systems. So that is pumping plus gravity,
Yeah,
and you need to consider this pumping cost as well.
because in small city they have 20, 50 disposal stations, 20 to 15 disposal stations.
Right.
So they just pump from one of the city to other.
Right. Great. 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 So okay. So can you please confirm? So let's summarize. Okay, Ali.
Yeah.
Can you please confirm the agenda so that it goes as per your I mean you drive the demonstration instead of me giving some standard demonstration.
Thank you.
So just to summarize, you work on AutoCAD, so you want to know all the features that are there in SewerGEMS that will be helpful for you while using AutoCAD, right?
Yes, sir. Yeah.
At the same time, you're also interested in knowing the storm and sewer combined aspects in your schemes since you have projects for combined sewerage networks, right?
Yes, right. Yeah.
Now, if you have rejected, I mean, my query that whether you use GIS or not, so I'll just delete this GIS aspect from that or agenda.
Yes.
And now you create DPRs in which you need to have graphs, tables, you color code your network and you annotate your network, right?
Yeah.
Now, till today, you were not able to do these extended period simulations since you were using some standard Excel workflow.
Yeah.
And but now you are also saying that you want to have pumping and gravity systems combined analysis, right?
Yes, sir. Yeah.
So that it also means that how much time you also are interested in knowing how much time does it take to fill the wet well, right? Where all the
Yes, you're
water is
right.
being
Yeah.
collected. So what is the time after which I should start my pump? For how many hours should I pump water or gray water from that wet well to another manhole on the upstream side? So as to optimize my pumping or energy cost. Is it that?
Yes, you're right. Yes.
Now, you are also dealing with some greyfield projects, I mean brownfield projects and some greenfield projects, right? That
Yes.
means you're having projects which are having existing infrastructure, as well as
Yes.
you're supposed to design and rehabilitate or expand the existing infrastructure for the expansion schemes, right? The projected expansions,
Yes. Right.
the future expansions. Great. So you typically design your network to for the next 15th and 30th year,
Yes, you're right.
for which you have some constraints for minimum or and maximum velocity, minimum slope, and you also try to optimize to reduce the cost of excavation.
Yes.
Now, you also say that I want to have, you also consider cost optimization as an important parameter while designing or creating these detailed project reports, right?
Yes, right.
In which now, if I just need to segregate this cost optimization, the part A becomes optimal sizes of the pipes, right?
Yes, right.
Optimal diameters of the pipes and optimal invert levels of the manholes, right?
Yes, you're right. Yeah.
So if I get optimal invert levels for the manhole, I'll be indirectly getting optimal cost of excavation,
Yes, right. Yeah.
right? And now you are having old infrastructure,
Yes.
right? So I'll just delete it or I'll modify it with scenarios. Now, This is an amazing thing that you must be aware as you are a user of AutoCAD. So while using with the use of scenarios, you can model anything that comes in mind while thinking about your design. For example, what will happen if there is a sudden expansion towards the north of your waterage or sewerage system, right?
Mhm.
What will happen? What is my existing situation? What will happen after 15 years? What will
Yeah.
happen after 30 years, right?
That's right.
How my design will look after 45 years, right?
Yeah,
So
that's
you
right.
can create n numbers of I mean, you can create literally unlimited scenarios using SewerGEMS. So just as we go, I'll just start my demonstration if everything is fine at your end. If you have some
Yeah.
queries, can you please tell me so that I can include your queries or the challenges that you are currently facing in my agenda so that we can just right away discuss it so that I can give you a technical proof of what can be done and what cannot be done using our software
Yes,
solutions.
just one more thing.
Yes, sir.
That because I sometimes receive shape files from the client,
Great.
which are shape files. Yeah,
Hmm?
but they are not. Sometimes I cannot use them
You cannot,
properly because
yeah, they are not readable.
yes, and it's I cannot scale them, so there's a big issue. And then I'm gonna have to rewrite everything.
Sorry, can you please repeat yourself?
For example, I'm importing the shape file, but it doesn't
Hmm.
open because it doesn't support it or object is not uh, compatible. Like
So
these
you
kind of
open
messages.
that shapefile in what? In AutoCAD?
Yeah, yes, in AutoCAD. Yeah.
Okay, so I'll also see there are, see, let me make a new. So when we say AutoCAD or SewerCAD, can you see the screen?
Yes, I can.
It's completely integrated with AutoCAD,
Right. Yeah.
but it's not integrated with GIS.
Okay. Okay.
So that's the reason. That's the basic reason that that you are getting an error, right?
No, maybe yeah. Yeah.
And if you upgrade to GEMS, water gems or sewer gems, which is geospatial,
Mhm.
environmental, modeling, software.
Okay.
So this is a full form of GEMS. So if you upgrade to GEMS, you will have complete integration with AutoCAD as well as GIS, which will uh, which will help you to talk with geospatial softwares like GIS,
Okay.
right? So that's the clarification that I would like to give you on this front, since you are having some issues in shapefiles, reading shapefiles.
Okay.
Okay, so should we block this agenda?
Yes, we can.
All right, so let's start our demonstration.
Okay.
First of all, thank you very much for your time, Mohammed. Uh,
Thank
so
you.
can you see the screen now?
Yes, I can. Yeah.
Can you see this Bentley Sewer Gems?
Yes, I can.
Now this is how your software will look when it's on your system, right? So
Mm.
it is version V8i, select series
Okay.
5. And when you install SewerGEMS, you'll also get SewerGEMS for ArcMap. If you can confirm that you can see this SewerGEMS for ArcMap. Can you see this?
Yes, I can. Yeah.
And then you'll also get SewerGEMS for AutoCAD.
Okay, this is red one.
Right, that the red one, right?
Yes.
And similarly, you'll have SewerGEMS for MicroStation.
Yes, I can see the green one.
Now my only intention to show you this is, since you are an AutoCAD user, you can open SewerGEMS from within AutoCAD. By
Okay.
by this I mean that everything will look like AutoCAD with all the functionalities and features of AutoCAD completely integrated with all the functions and functionalities and features with of SewerGEMS.
Okay. So working within the AutoCAD.
Yes, that means you can work on SewerGEMS from within AutoCAD,
Okay.
which I'll demonstrate you at the end of this our major agenda.
Okay.
Okay, so let me open SewerGEMS. So now this is how typically SewerGEMS look like. Can you see the screen?
Yes, I can. Yeah.
Now, since you are a AutoCAD user, everything is just AutoCAD, isn't it?
Yeah, it's similar.
It's same rather. Everything is
Yes.
same, right? But the engines that work behind these softwares, AutoCAD, WaterGems, and SewerCAD, SewerGems are different. But the graphical user interface is identical.
Yes, right.
So by this I mean when you say that you know 100% AutoCAD, you are knowing 98% of SewerGEMS already.
Okay.
So you won't have to invest time and resource in learning completely new software. You know the software, just the technical stuff differs. The engines differ.
Yes, this input in is different. Yeah.
Right, the input and output, the language differs. But everything will be same, rest
That's
of the
right.
things, right? So as you know, we can use this layout toolbar in order to create and insert elements in our network. You can insert some conduit, you can have open channels, you can have gutters next to your
Yes, right.
curves on the roads. At the same time, you can also have pressure pipes for your pumping mains.
Yeah.
After that, I'll just take you through this layout. You'll have catch basin,
Yes.
which will gather the runoff from the catchments.
That's right.
Then you can have manholes for sanitary network node.
Yes, right.
Then you can have cross sections, that is channels, open channels. It can be a
Okay.
rectangular or trapezoidal, or it can be a non-prismatic as well. You can have
Yes.
outfall,
Outfall.
a catchment, okay,
Yeah.
and then you can also have this detention pond. If you are doing rainfall analysis in urban areas,
Okay.
we generally detain water for some time and then release
Yes,
it
right.
to the in order to avoid overflows, right?
Yes, right. Yeah.
So you can also design your detention pond. You can analyze how much time does it take to fill that pond, after what time the backwater graph changes, right? The profile changes. You
That's right.
can do stuff like that, right?
Okay.
And then you can have other features like you can install your pumps, you can have wet wells, you can have SCADA connectivity as well with your sewerage infrastructure networks,
Okay.
right? Now I'll just navigate to a typical network like this. Can you see the network?
Yes, I can. Yeah.
Now I have created this network by using an AutoCAD file as a background reference. I just take that AutoCAD background file. Now, as you know that whenever we take some background file as our reference file,
Yeah.
our network can be considered as a scale network, and you won't have to insert and allot all the lengths of the pipes individually, right? It will be automated, right?
Can you just tell me how to adjust the scale of the playground?
Right. Excellent question. So for that, you need to go to tools, and then you need to go to options, and in
Yeah.
options you need to click this drawings tab. Okay.
So, okay.
and here you'll have the scale factor, so that you can say that 1 centimeter in AutoCAD is how many meters, right? You can adjust the scale.
Okay.
Can you see the
Yeah.
screen?
Yeah.
So that's a great question. Now, say, can you see the screen? Can you confirm?
Yes, I can. Yeah.
So now this is our network. Sanitary water is being collected at manhole 1, from where it is transferred to manhole 2, manhole 3, and ultimately to our outfall element, which is over here. Right?
Okay.
Now this is a typical, a very small network, and I've annotated. Can you see on the left top of your screen? I've annotated the network on the basis of the slope.
Okay.
Now this 0.00 is nothing but the slope of pipes.
Okay.
Now this is so the slope should never be 0, right? It means completely
Yeah.
horizontal laid pipes. So the reason
Sure.
behind changing the slope to 0 is to show you that our invert levels are 0.
That's right. Yeah.
So hence the slope is 0, right? So now
Mm-hmm.
using T-Rex, which you are already aware of, T-Rex is terrain extraction tool, which
Yeah.
extracts terrain from the contours. You are aware of that, right?
Because I use the spot levels basically.
Great. So you can either use spot levels or contours, whatever data that you have, and you can assign the ground elevations to your elements. But for invert
Yeah.
elevations, the software will automatically calculate the invert elevations. It will design the network to optimize the invert elevations and to achieve the velocity and slopes for efficient flow of water in the network,
Okay.
right? So
Okay.
as you know now, all the manholes are having ground elevations, but the invert elevation is 0, right?
Yeah.
And let's take a look at the conduit. And all the pipes are having a diameter of 300 mm. Now I have randomly selected 300 mm as a size. It can be 200, it can be 100. It's just it needs to be non-zero value,
Yeah.
right? So if you do not want to have 300, I can just globally edit it and change it to, let's say, 100 mm pipes, right?
Okay.
I won't worry a lot much on this point, because the software is anyway going to calculate the diameters for me depending on the design constraints. So I've just selected the size as 100 mm, and it will change depending on the flow through the pipe,
Oh.
right? Hello?
Hello. Yes, I can
Yeah.
hear you.
Yes, great.
Uh,
Now,
okay. How to assign the load then?
yes. Now for load, you'll have this sanitary load control center under tools menu.
Okay.
Okay. If you click this, it is very much identical to the demand control center in AutoCAD,
Yes. Yeah.
right? You can have unit loads, unit sanitary loads, and you can have known loads. For example, if you know the exact flow of water that is going to be loaded on that manhole, you can use demand control center. If you do not know, you can just, if you know the population information of that area, you can use unit sanitary loads like this, like
Okay.
in this case, right? So this is a
Okay.
residential area, and it is having 5 buildings, 4 buildings, 3 buildings, 2 buildings, accordingly,
Okay.
right? But at the
Yeah.
same time, you can also have the known base flow considered. Can you see this?
Yeah. I can.
Right. So this is how you put in you load your system, right?
Okay.
And then you the user or you can go to components and click this default design constraints, under which you can stress your network, you stress your design for the constraints. For example, if you are interested to have, if you are having some, hello?
Yeah, yeah.
For example, if you are having some minimum velocity, maximum velocity constraint, you can just specify it over here.
Okay.
At the same time, you can just specify your cover constraints, that my minimum cover must be more than 0.91 meters and it should be less than 4.5 meters, right? At the same
Okay.
time, you can also specify your minimum and maximum cover, slope constraint. Okay.
Okay.
Now, when you define these constraints, you can create a design scenario.
Okay.
Can you see the scenario over here? You can create a design scenario, and when you compute this design scenario, okay, when you compute this design scenario, it will optimize the network for you. Like, can you see this slope changing from 0 to 0.003?
Yeah, yeah. It
Now
changes. Yeah.
it has changed. It has automatically designed the invert levels.
Okay.
Okay. So now let's take a look. It is also showing us the flow direction. And let's now take a look at what are the invert levels. Now can you see these were our ground elevations and these are our invert elevations.
Yes, I can.
Now from 0 it has optimized these invert elevations so as to adjust your slope constraint, right, and velocity
Okay.
constraint. So depending on the velocity and the slope constraint, it has adjusted its invert levels, as you can see on the in the table over here. Okay.
Yes, I can see.
Now let's take a look at the conduit table. Now in your conduit table, initially all the pipes were of 100 mm size, right?
Yes, yes, it was.
Now it has optimized the size from 300 or 100 to 200, right? In order to achieve velocity and flow constraints,
Yeah.
right? And then you can
Okay.
also have features or these results as you get in WaterCAD, like velocity, right?
Mm-hmm.
And then what is the diameter, OD, outer diameter,
Okay.
right? And other results. What is the flow and etc.
Okay.
Okay. Now let's take a look at the profile. For example, in this case, we have this profile. I have created profile 1. Now, can you see the profile?
Yes, opening. Yeah, I
Yeah.
can.
Now, the green line that you can see on the top is the ground elevation.
Ground level.
Right, ground level. And this is your conduit. The blue line, the dark blue line that you can see on the screen is your HGL, hydraulic grade line.
Okay, so
Now, if I
the
just
line. Okay.
go and zoom a little bit over here, now can you see this?
This is stop. Yes, and now I can see.
Okay, so can you see the blue line, dark blue line? It's
Yes.
your HGL, water surface elevation. This vertical
Okay.
column is your manhole.
Yeah.
And this red line over here, can you see the red line? This red line?
Yes, I.
This is your total energy line.
Okay.
Okay, so
Okay.
now this is the profile that you got when you set your constraints to some value, right? Minimum and
Okay.
maximum constraints to some value. Now you can redesign your network based on some other values, right? Some other constraints. You can modify, you can tweak the constraints in order to get more efficiency, right?
Okay.
And then you can compute your network again, and then you can see what is the new design scenario. Now this is the
Okay.
design 2. Now it has changed the slope completely. Right? Can you see the profile?
Yeah.
Now, for example, this was the profile for design scenario 2, and this is the profile for design scenario 1. You can just compare profiles depending on what scenario you are looking forward to having,
Okay.
right?
Yeah.
And so this is how you create, you model, and you design a completely new system. Now I'm just going to take you to some of other features that will help you understand the use of this software for your projects locally. Can you see this image over here?
Yeah. Just one thing I want to
Okay,
clarify.
okay. Yes, yes,
For
please.
example, let us constraint is increase in population. So how we inbuilt this one that after
Sorry.
15 years, this how what where replacement of pipes.
Sorry. Can you please repeat yourself?
For example, manhole 1, 2, and 3. The population is increased after 15 years. Right?
Absolutely. Great.
So how will tell us that this pipe will be undersized after 15 years, so you need to replace with the size.
Absolutely. So for that, I'll just show you this scenario. I'll come to that point. Is it
Okay,
okay?
okay.
Or
Yeah.
let me just clarify that. So for that scenario, you can have, you can create a new sanitary loading alternative. Can you see this sanitary loading alternative?
Yes. Yeah.
You can project the future loading on the system, and you can create a new
Yeah.
scenario for that. And then you can check the D by D ratio for that new the additional loads, right?
Okay.
Okay. So, but I'll come to that point. I'll explain it to you in details.
Okay.
Okay. Can you see the screen?
Okay. Yes, I can. Yeah.
Okay. Now this is an aerial image that we took, right? And it's a scaled image. And these are the building blocks. Can you see?
Yes, I can see. Yeah.
And the brown lines that you can see on the screen are nothing but the trunk mains, sewer mains.
Okay.
Now it's a huge area. Can you appreciate the scale of the area?
Yes, I can see. Yeah.
So it's pretty much. Sorry.
The background is in his image or in his GIS?
It's an image. It's a JPEG file.
Okay. JPEG. Okay.
Right. So, and I'll just navigate you through the network. So we have our trunk mains over here, which collect water, and all the water is initially collected in this wet well. Can you see the wet well?
Okay.
Okay. And in this wet well, we have a pump station. Can you see the set of pumps?
Okay.
Which pumps water to a higher elevated manhole. Can you see this?
Yes, two pumps, I guess.
Yeah, two pumps pumping water to this manhole.
Okay.
Okay. So from where the water is carried to the final out this water treatment plant, sewage treatment plant,
Okay.
which is over here, WTP. Can you see this wastewater treatment plant?
Yes, I see. Yeah.
Okay. So this is a big network, a really big network to the scale, a real live network. Okay.
Yeah.
I just wanted to show this to you so that you will appreciate that, oh yeah, this is what I want and this is what I can do using this in the near future, right?
That's right. Yeah.
Now, what I've done is I've created a scenario. Now this is whatever you can see on the screen is my existing network. Okay.
Okay.
And I have collocated my network on the basis of the diameters now, as you can see.
Okay.
Okay. And now, this is just sanitary network.
Okay.
Okay. Now I also want to have storm water analysis or consideration in the same network,
That's right. Yeah.
right? So for that, what I'll do is I'll just create a scenario. Can you see this 1 year storm event?
Hello?
This scenario
Sorry,
on the
can you?
right hand side top.
Yes, I can see. Yeah.
No, now I have created this scenario for 1 year return period, and I'll just make this current. Okay, make this as our current
Okay.
scenario. Now, as you can see, some green shades are appearing, right? Some green polygons
Yes.
are appearing on the screen,
Yes. Yeah.
right? These polygons are nothing but my catchments,
Okay.
right? Now, I'm zooming in, okay? I'm zooming into this particular catchment. Can you see the catchment? The border of the catchment is highlighted in red color,
Yes. Yes. Yes.
okay? If I now
Yeah.
go to this catchment's properties, you can select the runoff method for this catchment. Whether you are considering modified rational method or time and area based method or unit hydrograph method, you can just specify the properties of this or the consideration depending on which the runoff will be calculated.
Okay. Okay.
Okay, and which is very much flexible so that the use it all depends on the user how he or she wants to consider the
Okay.
runoff from the catchment, right?
That's right. That's right.
Now, as you can see, if I let me just zoom it again. Can you see this dotted line over here?
Yes. Yes. Black one.
It's a small thin line, dotted line,
Yes.
and then it is indicating to this manhole over here. Can you see
Manhole.
this manhole?
Yes,
Let
I
me
can see
just
now. Yeah.
let me just take off these colors. Now can you see this manhole? That dotted
Yes.
line
Yes.
is joined to this manhole. That means all the water from this catchment, this huge catchment, hello,
Yeah. Yeah.
is going to be collected on this manhole over here. That means this catchment is contributing the runoff to this manhole. So and hence
Okay.
this dotted line, so that the modeler understand that which catchment is contributing flow to which manhole or catch basin.
Okay.
Okay. Similarly, we have other catchments as you can see on the screen.
So this dotted line is created automatically, or we have to assign it?
Absolutely. Yes, it is created automatically. So in this properties of these catchments, you just need to specify the reference node, the
Okay.
outflow element. Can you see this outflow element?
Yeah. Okay. Yeah.
Okay. So when you reference that catchment, you can reference that catchment to any element.
Okay.
Okay. And so this is how your network is. Okay. And now I want to consider the storm and sanitary combined analysis done together on this network.
Okay.
Okay. So for that, I'll just go to add my storm data. Can you see the storm data?
Yes, I can. Yeah.
Now I'll just open this storm data, and I have some kind of storm data like you can see on the screen.
Yeah.
Okay. Now it's 1 year return period, 24-hour storm data. It's 10-year return period, 24-hour storm data. And the relationship is between time and depth of water.
Okay.
Right? And it's just so this is how, this is what the storm data that I have presently. But you can also have, it depends on the data that we actually have, right? It can
Right.
be intensity, duration, and frequency curve. So you can create a curve equation file or a table equation file, right? It
Okay.
can be a time depth relationship. It can be time intensity relationship. At the same time, it can be some rain file which the government has.
Hello.
Right?
Yeah.
So for this particular example, I have this time depth relationship for the written period of 1 year and 10 years, as you can see on the screen.
That's right. Yeah.
Okay.
Yeah.
And now, what we are going to do is we are going to compute this scenario. Okay. Hello.
Yeah. Yeah. I can hear it. Yeah.
Now we are going to compute this scenario, but before computing, let me just go to analysis and calculation options.
Okay.
And can you see this 1 year wet weather EPS
Yes, I can see.
dynamic wave implicit?
Yes, I can see. Yeah.
Now it is, see, I'll just pop it up. Can you see this active numerical solver?
Yeah. It's opening.
You can see, right?
Just wait. Just wait.
Okay,
Because
okay.
yeah, I can see now.
Now, this software, when I say SewerGEMS, it's actually a combination of 4 different softwares.
Okay.
It will have explicitly swim analysis solvers,
Okay.
swim solvers, and then it will also consider GVF convex flows analysis, that is
Okay.
SewerCAD engine, and it will also have GVF rational engine, which is Tomcat engine.
Okay.
And then it will have implicit SewerGEMS dynamic wave engine, which follows the Saint Venant's equations.
That's right. Yeah.
Right? So that you'll be able to see the behavior of your network project or subjected to some storm event over a period of time, like EPS.
Okay.
Okay. Now let me show you that. How does it actually look like? Calculation options are closed. So I'll just compute this network. So it's solving the dynamic wave. So it generally takes some time because it solves hundreds and thousands of equations. So okay,
Yes. Yeah.
you're aware of that, right? So now it has it has computed everything for us. What I'll do is I'll color code this
Yeah.
network. I'll color code this network for flow.
Okay.
So I'll color coding this network for flow. Absolutely.
Okay.
Okay, so everything is looking green.
Yeah.
That means the flow is less than 13, but the maximum flow, if you observe, it's approximately around 67. Hello, Ali, can you see your
Yeah.
connection? All right. So the maximum flow was around 67 liters per second. Pardon me. Now what I'll do is I'll compute this network like I promised you. I'll compute this network over. See this time browser over here.
Yeah.
Now I can see what is happening. Can you see what is happening? See, the flow has increased.
With it.
12:06 a.m. Just 1 minute, huh? Let me see. Initially, the flow increased. Then it was transferred to another set of pipes. Then another. Then another.
Okay.
Then another. And then it was finally. Can you see the dynamic wave? See, initially.
Yeah, I can see that.
The flow was contributed over here. Rainfall occurred in this catchment. Okay,
That's
water
right. Yeah.
water flew from this part to this part, and then
That's right.
it
Yeah.
moved to the next conduits in next 3 minutes. In next 3 minutes, it was between these inside this conduit, and then these
Okay.
conduits,
Right.
and these conduits, and at the end, it was collected to this wet well over here.
That's right. Yeah.
Right, and now this was just to explain you how it calculates things, but let me now play it completely. So now, as you can see, time is changing, and after every 3 to 2 minutes it will calculate results for you dynamically, and it will make you understand that in a short span of 5 minutes rainfall how your network will behave, so that whether you can check whether your network is safe for a return period of 10 years for a 5 minutes rainfall duration, right?
Okay. Okay.
Right. Now
Right.
it's animating like.
Yeah.
Now this is not
Actually,
quite
because sorry.
you can also go. Hello, you were saying something.
Yeah. Then this is what we need because how the system behaves when there's sudden rain.
Exactly. Not just that, Ali, you can
Yeah.
also go on to create graphs like this, depending on the runoff method that you adopt.
Okay.
Okay. So can you see a detailed graph for 24 hours?
Yeah.
And then you can compute, you can navigate your system, you can scroll your system to this point. And when you scroll your system to this point, you can just see what is the behavior of your system at that point of in time
Okay.
on the network, and then you can compute it. Okay.
Yeah.
Not just this, you can create dynamic profiles. Okay, like this. Can you see? You can create dynamic profiles, and you can then compute your profiles you can check how much water is being filled in the network, how the catchments are contributing flow in your network, right?
Right. Yeah.
Now it's a bit slow, but now you'll appreciate when it approaches 11 a.m. because that's when the rainfall really occurred, right? As you saw, it was
Yes.
midday rainfall. Can you see the water levels changing dynamically?
Yes. Yeah. They're changing.
Now,
So it can give us the overflow conditions as well.
right. It will not only give you that, it will also help you understand that whether the fraud number is changing drastically or not. Because as the fraud number changes drastically, it may occur in some hydraulic jump in your network that may damage your pipes, right? So transition between supercritical flow to subcritical flows, and see the dynamic. It will also calculate the profile of the slope water level, M1, S1, S2. Actually, the water will the network will become empty. And similarly, you'll have some other profiles like this. Now, this is an interesting profile. Can you see this profile? Hello, Ali. Ali? Ali, can you hear me?
I can hear, but I guess Alicia cannot hear you. At least we cannot hear you. Just 1 second. Because it's 11 a.m., so maybe due to power outage, it's a lag of 2-3 minutes.
Mm-hmm.
Because at every 11:15, 11:30, something like that, normally we have outages in different cities, different schedules.
Right.
Okay, so let's wait for seconds.
Okay.
Hopefully, मैं कोशिश तो कर रहा हूँ.
चले, let's see. आपकी एफर्ट जो है हमारे भी काम आएगी एंड एक्चुअली हम भी चाह रहे हैं कि अथॉरिटीज और ये सब लोग दे शुड रियलाइज एक्चुअली, क्योंकि जिस तरह का हमारा इंफ्रास्ट्रक्चर है थ्रू आउट द कंट्री आउटडेटेड है, फिर उसमें प्रॉब्लम्स हैं, फ्यूचर सिनेरियोज कभी किसी ने आई गेस कभी किए ही नहीं कि कल को अगर पॉपुलेशन बढ़ती है, सिटीज आर ग्रोइंग एट अ वेरी फास्ट स्पीड, तो इस चीज को मेरा नहीं ख्याल कि कोई भी जो है वो पहले कैटर करते हैं, और स्पेशली आई गेस ये वासा और जो अथॉरिटीज हैं वो भी इस चीज का ध्यान नहीं रखते हैं. आई डोंट नो व्हाई.
नहीं, वो असल में वो डिमांड ड्रिवन ऑर्गेनाइजेशंस हैं. फॉर एग्जांपल पुलिस ने कह दिया कि फला इलाके में पानी नहीं है, बस पानी पहुंचाना है, ठीक है, तो देन दे नेवर बॉदर कि ऑप्टिमाइजेशन हो गया, इकोनॉमिक सब्सिडी, वो कहते हैं भाई हमारे 500 मिलियन अप्रूव हो गए, वो खर्च कर.
बिल्कुल ऐसे ही है.
इट्स लोडिंग.
ओके.
अली भाई बताइएगा जब आप
तरफ से.
ओके, आई कैन सी आल्सो.
So this is overflow conditions, I guess. Yeah.
Hello?
Yeah, can you hear me?
Yeah, I can hear you.
Yeah, good.
Now, देखो आपको ये स्क्रीन दिख रही है?
Yes, I can see.
Now, see, this is what we call as engineering profile. Now, such engineering profile enable the user to understand कि यहाँ का manhole का नाम कितना है, उसका ground elevation कितना है, invert elevation कितना है, right?
Okay.
What type of material that pipe is built of?
Okay.
उसका diameter कितना है, उसका slope कितना है, right? ये सारी
Okay.
चीजें, उसका लेंथ कितना है, ये सारी चीजें आपको ऐसे प्रोफाइल्स में मिलती है। अभी इंटरेस्टिंग थिंग इस प्रोफाइल की ये होती है कि दिस इज अ स्केल्ड वन, इट इज टू द स्केल प्रोफाइल। ओके,
Okay.
नाउ आई एम जस्ट गोइंग टू दिस पार्ट ऑफ द प्रोफाइल, कैन यू सी दिस पार्ट?
Yes, I can see.
नाउ इसमें क्या है कि ये पूरा पानी मैंने इस एरिया से ये पानी इकट्ठा किया इस वेट वेल में, यहाँ पे,
Okay.
यहाँ इस वेट वेल में इकट्ठा किया, और यहाँ पे मैंने इसकी एनर्जी बढ़ाई पंपिंग स्टेशन डाल के। यहाँ पे मेरा पंप
Okay.
है, यहाँ से कैन यू सी द वर्टिकल ब्लू लाइन?
Yes, I can see.
दैट मीन्स द HGL इज इंक्रीजिंग बिकॉज ऑफ द पंप। वो पंप से HGL बढ़ गई है, और यहाँ से मैंने इस मैनहोल तक के मैंने पंप किया पानी,
ठीक है।
ने इस पॉइंट से इस पॉइंट में पंप किया, एंड देन
Okay.
अगेन इज अ ग्रेविटी फ्लो, और फिर यहाँ कहीं तो मैंने फिर से पंपिंग किया। सो ये ऐसे बड़े बड़े प्रोफाइल्स आपको मिलते हैं, टू द स्केल प्रोफाइल्स।
Still siphoning the pipe because of grade.
सॉरी,
It's just a siphon on the portion. क्योंकि ये आपका ग्राउंड लेवल ऊपर है, इस वजह से आप पंपिंग है, अदरवाइज इट हैज
राइट राइट राइट, एब्सोल्युटली, ये बहुत ऊपर जा रहा है इसलिए मैंने इधर पंपिंग किया हुआ है। इधर से ये फिर से अंडर ग्रेविटी है, और यहाँ जाके मुझे फिर से एक बार दोबारा पंपिंग करने की जरूरत पड़ रही है। सो इट इज प्रॉब्लम स्पेसिफिक, इट इज प्रोजेक्ट स्पेसिफिक, जो कि मैंने वो पंपिंग सिस्टम डाली हुई है उसके यहाँ।
ओके
ओके, एंड और एक इंटरेस्टिंग बात इन प्रोफाइल्स का ये होता है कि यू कैन एक्सपोर्ट योर प्रोफाइल टू DXF, यानी ये प्रोफाइल जैसी है स्केल्ड प्रोफाइल, ऐसी की ऐसी आप, हाँ जी, तो ये ऐसी की ऐसी आप यहाँ डाल सकते हो, एक्सपोर्ट कर सकते हो ऑटोकैड में।
ओके,
तो ये एक चीज मुझे आपको बतानी थी। और दूसरी एक चीज होती है कि आप कंट्रोल कर सकते हो। देखो मैं इसको कंप्यूट कर रहा हूं इस प्रोफाइल को। सी, कैन यू सी आपका पंप का बिहेवियर? कभी ज्यादा एनर्जी डाल रहा है वो, कभी कम एनर्जी डाल रहा है, डिपेंडिंग ऑन द वाटर लेवल इन द वेट वेल। हाँ, सो दिस इज नॉट अ स्केल्ड वन, बट जो मैंने इंजीनियरिंग प्रोफाइल दिखाई थी आपको, दैट इज अ स्केल्ड वन। सो यहाँ पे ये बहुत ही ऊपर नीचे दिख रहा है प्रोफाइल, ऐसा नहीं है वो, तो वो इंजीनियरिंग प्रोफाइल में भी आप देख सकते हो
स्केल्ड का इशू।
हाँ जी, ओके
जी जी।
सो नाउ यही चीजें, ये सारे चीजें आप यहाँ पे भी देख सकते हो कि कैसा वो प्रोफाइल बदल रहा है, कौन से कितने बजे, कौन से पाइप्स में ज्यादा फ्लो है। राइट, ये रेड जो पाइप्स है इधर, यहाँ इनमें ज्यादा फ्लो है। राइट,
ओके,
ये भी आप देख सकते हो। और
फ्लोज विथ टाइम।
हाँ, फ्लो विथ टाइम। ओके
ओके,
फिर यही सिस्टम आपको, मान लीजिए यहाँ पे ऐसा लग रहा होगा कि ये सिस्टम अभी तो एकदम परफेक्ट है, ठीक है, मगर जब मैं 10 ईयर का रिटर्न ईयर्स देखता हूँ, और जब मैं 10 ईयर्स को जब मैं स्टॉर्म के लिए एनालाइज करता हूँ, तब शायद से ऐसा हो सकता है कि कुछ मैनहोल्स ओवरफ्लो कर रहे हो। राइट, वो भी आप एफिशिएंटली देख सकते हैं।
एक सिनेरियो था एग्जिस्टिंग सिचुएशन।
राइट, प्रेजेंट सिचुएशन में कुछ
नॉर्मल कंडीशंस में,
राइट, कुछ मैनहोल्स ओवरफ्लो हो रहे हैं क्या, वो देख सकते हो। फिर इसी सिस्टम को मैं अभी ना डायमीटर्स के बेसिस पे कलर कोड करता हूँ।
ओके,
सो ये जो आपको दिख रहा है, ये मैंने कलर कोड किया हुआ है डायमीटर्स के बेसिस पे। ओके, अभी मान के चलिए कि मैंने अभी जो एग्जिस्टिंग नेटवर्क है, इट इज नॉट फिट फॉर 10 years storm event. So what can I do is I can increase the capacity to prevent overflow. See, I can create another scenario, और मैं बोल सकता हूँ कि मैं अभी इसकी कैपेसिटी को इंक्रीज कर दूं, यानी इसके डायमीटर्स को बदल दूं, सो दैट ये जो 10 इयर्स का इवेंट है ये अगर 15 सालों के बाद या फिर 30 सालों के बाद आए तो मेरा सिस्टम परफेक्ट होना चाहिए। तो कैन यू सी सम पाइप्स चेंजिंग कलर्स?
यस,
पहले ऐसी थी, फिर मैंने इंक्रीज किया कैपेसिटी तो द पाइप्स चेंजेस कलर। हाँ जी। और ये सभी चीजें मैं एक ही फाइल में कर रहा हूँ, यानी SewerGEMS की एक ही फाइल है इन विच आई एम क्रिएटिंग डिफरेंट सिनारियोज सो एज टू अंडरस्टैंड व्हाट इज हैपनिंग व्हेन सम चेंजेस आर डन टू द सिस्टम।
ओके,
राइट। इसी के जैसा मैं और एक आपको नेटवर्क दिखा रहा हूं जो ऐसा दिखता है। देखिए,
ओके,
इसमें ना मैं बैकग्राउंड लेयर्स ऑन कर देता हूं। अब ये जो ब्लू लाइंस आपको दिख रही है, 3 बड़ी बड़ी ब्लू लाइंस, ये स्ट्रीम्स वो एरिया के लिए। ये जो ग्रे लाइंस आपको दिख रही हैं,
ओके,
बड़े रोड्स हैं, राइट। और ये जो ब्राउन फील्ड आपको दिख रहा है, दीज आर द बिल्डिंग ब्लॉक्स।
ओके,
Okay, and along those blocks I have created a networks like you can see on the screen.
okay,
Okay, abhi now this network, let me compute this network. Sorry, now this network is completely, देखो सब मैनहोल से कहीं पे भी आपको कैचमेंट दिखाई दे रहा है क्या?
नहीं,
वो ग्रीन पॉलीगॉन?
नो, नथिंग सर।
नहीं ना। और इसका मतलब ये है कि यहाँ पे मैं स्टॉर्म इवेंट कंसिडर नहीं कर रहा हूँ, सिर्फ और सिर्फ सैनिटरी कंसिडरेशन है।
ओके,
ठीक है, ये सब कंड्यूट्स है, ये मैनहोल्स है, ये पूरा यहाँ पे मैं देखो यहाँ पे वेट वेल में कलेक्ट कर रहा हूँ यहाँ पे, और यहाँ से मैं फिर से पंपिंग स्टेशन डाल के यहाँ कहीं तो आउटफॉल है मेरा, इस आउटफॉल को मैं पानी, यानी वो सूरेज ट्रीटमेंट प्लांट होगा।
ओके,
ठीक है, तो ये मेरा एक नेटवर्क हो गया, एक सिनारियो होगा, मान के चलिए सिर्फ सैनिटरी लोडिंग का सिनारियो है। ठीक है, उसी के तरह मैं इस पूरे सिनारियो को डिजाइन कर सकता हूं, राइट। और मैं बोल सकता हूं कि आई ऑल्सो वांट टू कंसिडर द वेट वेदर एनालिसिस, वेट वेदर फ्लोज का भी एनालिसिस मुझे इस सिनारियो में करना है, एक ही सिनारियो में। ठीक है, तो मैं मेरे एक ही फाइल में मैंने सुअर का बनाया नेटवर्क, उसी के अंदर मैंने वेट वेदर का यानी स्टॉर्म वाटर हाइड्रोलॉजी भी मैंने कंसिडर करके नेटवर्क डिजाइन कर सकता हूं मैं। जैसे कि आप देख रहे हो यहाँ पे एक पॉन्ड है, डिटेंशन पॉन्ड, राइट। यहाँ पे कैचमेंट है, ये कैचमेंट इस डिटेंशन पॉन्ड को कंट्रीब्यूट कर रहा है, जहां से ये देखिए यहाँ पे OS दिख रहा है, OS, इट इज आउटफॉल स्ट्रक्चर।
ओके,
ठीक है, यानी ये डिटेंशन पॉन्ड में एक लेवल से ऊपर अगर पानी जा रहा है तो वो इस आउटफॉल स्ट्रक्चर में पानी जाएगा, जहां से ये पानी ये कंड्यूट से कैच, देखो यहाँ CS दिख रहा है, CS इज नथिंग बट क्रॉस सेक्शन।
ओके,
अभी देखिए मैं इसके प्रॉपर्टीज में जा रहा हूं, और इसका जो सेक्शन टाइप है प्रॉपर्टी का, इट इज क्रॉस सेक्शन। देखिए कैसा है, ट्रेपेजॉइडल है, जिसका मतलब ये है कि ये दिस इज अ ओपन चैनल, राइट। ये मैं चैनल से पानी यहां से ले रहा हूं, और यहां से वो पानी डिफरेंट क्रॉस सेक्शन से होते हुए कहीं आउटफॉल में जाएगा।
यस,
यानी जो रेन वाटर का है, मैं वो एक तो चैनल से भी कंसिडर कर सकता हूं जैसे आप इस मॉडल में देख रहे हो, या फिर वो सेम आप क्लोज्ड कंड्यूट्स में भी एनालाइज कर सकते थे जैसे आप इस मॉडल में देख रहे थे।
ओके,
राइट, यानी 2-3 प्रकार से आप आपका नेटवर्क डिजाइन कर सकते हैं। आप चेक कर सकते हैं कि क्या मैं यहाँ पे चैनल डालूं या पाइप फ्लो से ही वो कन्वे पानी अच्छे तरीके से हो सकता है, या यू कैन चेक योर नेटवर्क लाइक दिस एज वेल।
ओके,
ओके, So after this I'll just show you ये SewerGEMS for AutoCAD का मतलब क्या. अभी मैंने ये SewerGEMS for AutoCAD को जब मैं डबल क्लिक करके ओपन करता हूँ तब इट opens Autodesk AutoCAD. So ये AutoCAD ओपन करेगा and in AutoCAD I'll be able to do whatever things that I've shown you till now from within AutoCAD. अभी देखिए ये सब AutoCAD ही दिख रहा है.
जी जी.
एक सेकेंड, इट इज लोडिंग. मैं इसको क्लोज कर देता हूं. ओके, अभी देखिए जो सारी चीजें मैं SewerGEMS में कर पाता था वो सभी का एक रिबन आपको यहाँ पे मिलेगा.
अच्छा.
कैन यू सी दिस रिबन?
यस आई कैन सी.
यानी मैं यहाँ कंड्यूट डाल सकता हूँ, चैनल डाल सकता हूँ, गटर डाल सकता हूँ, राइट?
ओके.
सिनारियोस क्रिएट कर सकता हूँ, डिटेंशन पॉन्ड, कैचमेंट्स, ग्राफ्स, प्रोफाइल्स, राइट? ये सब चीजें मैं AutoCAD के अंदर से कर सकता हूँ, फ्रॉम विद इन AutoCAD, राइट? सो ये चीजें आपको बहुत हेल्प करने वाली है, क्योंकि आपका पूरा वर्कफ्लो में AutoCAD अगर A से लेके Z तक के हैं तो आपको SewerGEMS का स्टैंड अलोन इस्तेमाल करने की जरूरत ही नहीं पड़ेगी, क्योंकि आप एग्जिस्टिंग AutoCAD फाइल्स के अंदर आप आपका स्टोरेज नेटवर्क, स्टॉर्म नेटवर्क, आप टू द स्केल विथ ऑल द फंक्शनैलिटीज ऑफ AutoCAD आप यूज कर सकते हो.
ओके.
राइट? फ्रॉम दिस लेट अस नाउ सी कि क्या हमने हमारा ये सारी चीजों को कवर किया है. फॉर एग्जाम्पल मैंने अभी भी आपको AutoCAD का एक बताया, राइट? सो मैं इसको ना स्ट्राइक थ्रू कर देता हूं, ताकि मैंने AutoCAD का बताया, आपको स्टॉर्म और सीवर का मैंने कंबाइंड बताया, राइट? और फिर मैंने आपको ये भी बताया कि जो डिटेल प्रोजेक्ट रिपोर्ट्स है उधर ग्राफ्स की जरूरत होती है, वो ग्राफ स्केल्ड होना चाहिए. फिर हमको टेबल्स की टैबुलर फॉर्मेट्स में रिजल्ट्स लगते हैं, कलर कोडिंग करना होता है, एनोटेट करना होता है. ये मैंने आपको चीजें बताई. उसके बाद मैंने आपको ये भी बताया कि अभी तक आप एक्सेल में जो काम कर रहे थे उससे आपको सिर्फ स्टेडी स्टेट एनालिसिस कर पा रहे थे. अभी विद द यूज ऑफ SewerGEMS का इम्प्लिसिट डायनामिक वेव सॉल्वर आप उसका पंपिंग और ग्रेविटी का कंबाइंड इफेक्ट देख के आप एक्सटेंडेड पीरियड सिमुलेशंस या फिर डायनामिक वेव राउटिंग आप कर सकते हो. आप चेक कर सकते हो कि 5 मिनट के रेनफॉल में मेरा सिस्टम सेफ है कि नहीं है. फिर मैंने आपको ये भी बताया कि एक सेकंड, मैंने आपको ये भी बताया कि आप डिफरेंट कंस्ट्रेंट्स आप इस्तेमाल कर सकते हो, जहां आप वेलोसिटी को मान के चल सकते हो कि भाई मेरा वेलोसिटी यहाँ से लेके यहाँ तक के होना चाहिए. फिर आप वो चेक कर सकते हो विद द यूज ऑफ सिनारियोस की 15th और 30th ईयर में आप कैसा आपका नेटवर्क रहेगा, स्लोप और कवर की चेंजेस की जरूरत है क्या, वो आप चेक कर सकते हो. आपको मैं जब आपको जब सॉफ्टवेयर ऑप्टिमल साइजेस देगा और ऑप्टिमल इन्वर्ट लेवल देगा तो इनडायरेक्टली आप कॉस्ट ऑप्टिमाइजेशन ही कर रहे हो, राइट? फिर आपको मैंने सिनारियोस बताया, राइट? और आपको जो ये शेप फाइल्स का नॉट रीडेबल प्रॉब्लम था, ये मैंने WaterGEMS और SewerGEMS का मतलब उसका जेम्स का मतलब क्या होता है वो उसमें बताया, राइट सर?
ओके.
So with this, I would like to conclude this demonstration with your permission, like whether, huh?
Just one more information from your side.
Yes, sir.
For example, I'm receiving data in GIS, और लेकिन मैं यूज नहीं करता, लेकिन I receive data in GIS. तो इसको मैं कैसे अपने पर्पस के?
Right. Excellent point. Now, अभी आपको जैसे कि हेलो, हाँ जी, तो जैसे कि आपके पास GIS का डेटा आता है, तो मान लीजिए मैं अभी ना क्या करता हूँ, इस नेटवर्क को बेस मॉडल में लेके जाता हूँ. अभी देखिए ये मेरा बैकग्राउंड इमेज था, और ये जो पाइप, ये जो आपको बिल्डिंग्स दिख रहे हैं, दीज आर माय क्या बोलते हैं, GIS स्टफ, ये GIS का इंफॉर्मेशन है मेरे पास। फॉर एग्जांपल मैं आपको अगर ब्राउज करके दिखाऊं तो मैं, एक सेकंड ना, सुअर मॉडलिंग, सुअरेज मॉडलिंग SI, ग्लोबल टीम, ग्लोबल वाटर सेल्स टीम का डेटा सेट में मास्टर फाइल, एंड कैन यू सी दिस बिल्डिंग फुटप्रिंट, ये सब शेप फाइल्स हैं। हेलो हेलो
Yeah, yes.
हाँ, so these are the shape files that I've got.
Can you hear me?
Yes, I can hear you. Hello,
Hello, yes, you can. Yeah, hello.
can you hear me?
Yes, I can. Yeah, yeah.
Okay, okay. So ये सब शेप फाइल्स मैं इस्तेमाल करके मेरे नेटवर्क का डेटा इंपोर्ट कर सकता हूँ, उसके एलिवेशंस इंपोर्ट कर सकता हूँ, राइट?
Okay.
और मैं अगर मेरे पास कनेक्टिविटी मॉडल है
Mm-hmm.
तो मैं उससे मेरा नेटवर्क क्रिएट भी कर सकता हूँ। उसके लिए डिफरेंट टूल्स होते हैं जो वाटर कैड में भी है, जिसका नाम है मॉडल बिल्डर, लोड
जी,
बिल्डर और टीरेक्स। इन तीन टूल्स का इस्तेमाल करके मैं मेरे जीआईएस के डेटा को इंपोर्ट करके उससे मॉडल बना सकता हूँ, उसको एलिवेशंस दे सकता हूँ और उसको लोडिंग कर सकता हूँ, सैनिटरी लोडिंग या फिर स्टॉर्म लोडिंग, डिपेंड्स। So this is how my GIS data will be helpful for creating, loading the model and assigning elevations to all the elements in my model.
Okay.
Any other queries, sir?
So actually, Tani, I have to use it when I have a real information. So, इस बात पता चलेगा क्या प्रॉब्लम है, क्योंकि एग्जिस्टिंग इंफ्रास्ट्रक्चर को क्रिएट सॉफ्टवेयर ले लूंगा।
Hello?
फिर when I have a problem तो मैं आपको फिर दोबारा the real
Certainly,
example
sir. Certainly, I'm always there for you. So this is my email ID. आप प्लीज ये मेरा email ID नोट कर लीजिए, और
जी,
ये मेरा सेलफोन नंबर है,
जी,
आप
जी,
ये
हाँ,
भी
हाँ,
नोट
जी।
कर सकते हो। और whenever you have any problem or query, difficulty और कुछ सपोर्ट या फिर हेल्प की जरूरत हो, so you can contact me anytime. और आपको
Actually, we are not working in new cities. They are mostly old cities, so you know it's very difficult to
डेटा अवेलेबिलिटी, या आई कैन अंडरस्टैंड,
information और आपको पता है डेटा नहीं होता।
राइट। सही बात है।
Right. Tane, can you refer him to some B communities link so that he can also get help from there also?
Absolutely,
Because
it's an
that's a
excellent,
self-paced, yes, learning.
yeah, it's an excellent idea. Thank you for reminding me, अली। तो सर मैं ये कहने वाला था कि आप www.communities.bentley.com, communities.bentley.com, अगर आप ये साइट पे जाते हो communities.bentley.com, क्या हुआ, इंटरनेट कनेक्टिविटी नहीं है क्या? अगर आप communities.bentley.com पे जाते हो तो, और उसके अंदर हाइड्रोलिक्स और हाइड्रोलॉजी के फोरम में अगर आप जाते हो सर, so you'll have all the tech notes, आपको how to do this, how to do that, Wikipedia, can this be done, right? ये मैं ना इसको कॉपी करके यहाँ पे पेस्ट कर देता हूँ। So this is the URL. You can also go to communities.bentley.com, और ये आप जैसे कि वाटर कैड के यूजर है, हेलो,
हाँ जी जी,
तो आप जैसे कि वाटर कैड के यूजर, so you can just go to Bentley Water CAD and you can search and get connected with other users, global users of Bentley Water CAD, और उनको क्या दिक्कतें आई हैं, उन्होंने उनके क्या चैलेंजेस थे, उन्होंने खुद के चैलेंजेस कैसे टैकल आउट किए थे, राइट? तो ये आप कर सकते हो। अगर आपका कोई यूनिक चैलेंज है तो आप वहाँ पे पोस्ट भी कर सकते हो। सो ये काफी इंटरेस्टिंग जगह है और आई पर्सनली स्पेंड 2 hours ऑफ माई डे ऑन बेंटली कम्युनिटीज, सो आई ऑल्सो रिकमेंड यू, हाईली रिकमेंड यू टू बी अ पार्ट ऑफ बेंटली कम्युनिटीज.
That's great. Okay. So I need to get registered there.
सॉरी.
I have to register in communities, huh?
हाँ, ये आपका यूजर नेम साइन इन होगा, यूजर नेम पासवर्ड, उससे आप फ्री रजिस्ट्रेशन है.
अली भाई, अगर आप सेलेक्ट के ऊपर होते तो एक ही लॉगिन जो है वो सारी वेबसाइट्स के लिए वैलिड होता है, चाहे वो bentley.com है, चाहे सेलेक्ट सर्विसेज है, चाहे कम्युनिटीज है. बट करंटली क्योंकि आप सेलेक्ट पे नहीं है, सो अगर आपके एग्जिस्टिंग कोई अकाउंट है तो आई होप दैट कैन स्टिल वर्क फॉर कम्युनिटीज.
Okay.
तो वो आप देख सकती है.
ठीक है.
और एक चीज, सॉरी, और एक बात है कि ये रिकॉर्ड हो रहा है, ये पूरा डेमोन्स्ट्रेशन जो था ये रिकॉर्ड हो चुका है. तो
That's right.
अली गुंडल आपको ये ड्रॉप बॉक्स से शेयर कर सकते हैं इफ यू वांट टू हैव द वीडियो कॉपी ऑफ इट.
Yeah, sure.
So even that will help you out, right, Ali?
Yeah, definitely.
So और एक कॉपी मुझे भी दे दीजिएगा, सीसी में रख दीजिएगा.
Right, definitely.
मैं भी देख लूँ, हाँ, थोड़ा सा
Thank
quick
you, Tani.
learning हो जाए.
It's nice, really nice. Yeah.
Thank you, sir. Thank you for the opportunity. Thank you for your time and thank you for being
मैं आपको
patient
तंग
with me.
करता रहूंगा once I have it.
कोई बात नहीं सर, कोई बात नहीं, कभी भी.
बस सर आप ये डिसीजन ले लें आपको कब चाहिए, तो देन एवरीथिंग विल बी फाइन.
And definitely after Tani's presentation, I think I have no option.
Thank you very much, sir. Thank you very much for your compliment.
Right.
No, really, it's very helpful. Yeah.
So regarding the software trial version, Tane, do you think that we can provide it to Mr. Ali so that he can try at his own end?
What I see, generally I do not recommend to have a trial version if the user does not understand how to use the software, because कैसा होता है ये इंजीनियरिंग सॉफ्टवेयर का प्रॉब्लम ये होता है कि अगर हमको कुछ चीजें आती नहीं है ना, तो हमको खामखा वो चीजें, यानी वो सॉफ्टवेयर बहुत डिफिकल्ट है ऐसा लगने लगता है, राइट?
And sometimes he feels that these features are not there, but actually they are there, but he doesn't
are there,
right.
कंफ्यूजन क्रिएट हो जाता है. तो मैं क्या रिकमेंड करूंगा कि सी यू कैन हैव, आपने अगर मांगा तो हम दे भी सकते हैं ट्रायल वर्जन, मगर इट वोंट बी अ गुड एडवाइस टू गिव.
Okay.
Right.
Now it depends between you and Ali. So
I will discuss with him.
Right, sir.
Okay, Tane, I have one question which Mr. Ali raised with me in some of my previous discussions.
Right.
अगर इनके पास कोई ArcGIS का डेटा आता है, right? Just the data of ArcGIS. Does it import it into SewerGEMS या उसके काम करने के लिए is that enough, or to work with ArcGIS he needs to have a separate license of ArcGIS?
No.
अगर सिर्फ डेटा चाहिए सिर्फ.
सर आपके पास अगर सिर्फ डेटा आ रहा है तो आपको अलग से ArcGIS का लाइसेंस लेने की या फिर किसी और सॉफ्टवेयर की जरूरत नहीं है. आप SewerGEMS में आप पूरा ArcGIS का डेटा यूटिलाइज कर सकते हैं. मगर एक चीज और होती है, ये जो शेप फाइल्स होती है, GIS का इंफॉर्मेशन होता है, ये करेक्ट होना चाहिए. आप एडिट नहीं कर पाओगे वो इंफॉर्मेशन अगर आपके पास कोई GIS टूल नहीं है, जैसे कि बेंटली मैप. तो अगर आपके पास कोई GIS टूल है, GIS सॉफ्टवेयर है, तो आप कर सकते हो वो एडिट. नहीं तो फिर वो आपका सिर्फ जो गवर्नमेंट से आता है डेटा उतना ही आप रेस्ट्रिक्टेड हो जाते हो.
अच्छा.
You need to depend on that completely.
Okay, I got it. तो इसमें what is the minimum requirement for editing? कौन सा सॉफ्टवेयर होना चाहिए
मिनिमम? तो आपको SewerGEMS, जब आप कहते हैं तो SewerGEMS में आप कर सकते हैं काम. आप SewerGEMS में, SewerCAD में, दोनों में एक्चुअली शेप फाइल्स का इस्तेमाल कर सकते हो. मगर SewerGEMS का बेनिफिट ये होता है कि आपको ये 4 सॉल्वर्स इन वन सॉफ्टवेयर, स्टॉर्म और फीवर एनालिसिस आप एक साथ कर सकते हो, डिजाइन और एनालिसिस.
और एडिटिंग ऑफ मैप्स, अगर फॉर एग्जांपल डेटा जो मुझे थोड़ा बहुत एडिट करना है, GIS
का डेटा सर आपको
सॉफ्टवेयर होना चाहिए मेरे पास.
वो सर यू कैन हैव बेंटली मैप, और या फिर आपको अगर हाँ गवर्नमेंट से मिलता है तो यू कैन आस्क फॉर देम, मगर बेंटली मैप इज एनालॉगस टू और much efficient than ArcGIS. So you can have Bentley map as well.
And Bentley map.
I can use the Bentley map for ArcGIS as well.
Ali bhai, can you repeat your question again?
Can I repeat?
Yes, please repeat your question.
Can I use Bentley map to edit ArcGIS data as well?
Tane, can you answer this question?
क्या what
Tanik, can I use Bentley map to edit ArcGIS maps?
yes now the language see ये Bentley map और ArcGIS ये दोनों ना शेप फाइल्स में डेटा सेव करते हैं, उनका एक्सटेंशन शेप फाइल्स होता है, राइट? सो आपका शेप फाइल आप बेंटली मैप में भी खोल सकते हो, उसको एडिट भी कर सकते हैं।
that's good. Yeah.
और ArcGIS भी कर सकते हैं।
And Bentley map is quite cheaper than ArcGIS, I believe, on commercial aspect.
Okay. That's helpful.
Right. Chale. Any further question, Ali bhai, so that we can conclude this session?
No, it's okay. I think it's a very good first session. So I have an idea to go forward.
Okay, great. Okay, Ali bhai, looking forward, and inshallah फिर आपसे बात होती है. And Tane, thank you so much for your time.
Thank you Ali, thank you
Tane, thank you so much for your help, and it's really helpful.
Thank you sir, thank you for lending me this